Hello guys, welcome to Green Academy. My name is Sharad. Let's start the problem. Okay, the problem is a line RS having a length 90 mm is inclined 30 degree to HP and 45 degree to VP. The point R is 10 mm above HP and 15 mm in front of VP. And the end S is in second quadrant. Draw the projection of line. If you want to find out the trace, we can also find out the trace. Okay, this is the question. Okay, let's read once more. So, what is the length of the line? It's 90 mm and the name of the line is RS. And it's inclined at 30 degree to HP and 45 degree to VP. 30 degree to HP, that means theta. And 45 degree to VP, that means phi. Okay. The point R is 10 mm above HP, 10 mm above HP and 15 mm in front of VP. That means it's in the first quadrant. And the end S is in second quadrant. Okay, that's little bit different. The end S is in second quadrant. So it's a problem where one point is in first quadrant and other point is in second quadrant. Okay. So it looks like kind of difficult question, but actually it's not. It's a very simple problem. You just need some imagination. Okay, let's start the problem. So the procedure is very simple here, the same as before. You have to understand the basic structure of line rotation method. So this is your basic figure and you need to compare the question with this basic figure. That is very simple procedure. So first understand the question. So here this is our line RS, right? This is our first quadrant and this is second quadrant. The line, the point R is some distance above HP and some distance in front of VP. It's given. What is that? It's the length of the line. This is 90 mm. Length of the line is 90 and the point R is above HP, 10 mm above HP, and from here to here it's 15 mm in front of VP. Okay, so our front view and top view will be in reduced length. It's because the line is inclined to both HP and VP. Okay, so what is the procedure? So first, the procedure of line rotation is, first you have to make the line parallel to VP. This is our VP vertical plane, this is our HP. Okay, first you have to rotate the line keeping one point constant. I am keeping this point R constant and I am rotating this S from here to here like this. Okay, from here to here, R from here to here, and it will be like this. Okay, this is our new S, keeping the angle, that is theta, remain constant. So this I am not changing the distance from HP. I am not changing the distance of S from HP. That's how we keep this angle theta constant. So it will be like this. So it will be like this. In this figure, this is our R. We kept this point R kept constant, and this is new position of S. This distance, that is from here to here, I am keeping this distance constant. From here to here, that distance is equal to this distance. So this is how I am keeping this distance constant. That means this angle theta, I am keeping this angle theta constant. This is our R dash and S dash in the front view. This will be true length because RS is parallel to VP and its length is 90 mm. And what about this length? This is 15 and this is 10 from HP. This is 10 and this is 15 because I am keeping this. I kept this point R constant. And what about the length of this top view? We don't know the length of the top view, but it's a reduced length. Okay, this reduced length, this reduced length is same as that of the reduced length of the original top view, right? This portion got this original line got a top view and front view. The length of the top view is similar as that of the length obtained here. Okay, so after plane rotation, after this is our HP, after HP rotating HP horizontal plane by 90 degree, we will get, this will be our XY line, and this is our xy line. We can draw a figure like front view will be like this. So this is 10 mm above HP, this is R dash, and this is S dash, and this is R, and this is S. So can we draw this line? Yes, of course, because we know the value of theta and we know the true length. True length is equal to, I think this is 90 mm, right? 90 mm, and we will get the reduced length here. We can measure the reduced length. Okay, that is the first step. The next step is we need to make this line parallel to HP. Parallel to HP. That this is here the line is inclined at certain angle, theta angle with HP. So we need to make this angle parallel to HP, keeping the angle with VP constant. That means phi, we are not changing the angle phi. Okay, that means we are not changing the distance from VP to this point S. So after rotating the line, we can get this, we can get the figure like this. This is our line RS, and this is our first quadrant, second quadrant, this is VP vertical plane, this is HP. And after making the line parallel to HP, we can get a front view like this, and we will get a top view like this. So top view will be in true length because the line is parallel to HP, and this is the projection of top line projection. This is the top view. This is 90 mm. And what about this length? We don't know the length, but we can find out here. Find out from this figure. Okay. So you have to keep in mind one thing, because here after rotating horizontal plane, whatever the things in HP here, that will be go up. That means this will be our xy line. When this side go down, this will be go up. Okay, so whatever the projection in this horizontal plane, that will be above xy line. You must understand, in second quadrant, top view and front view will be above xy line. So how to draw that projection? First, very simple. You have to first spot the point R. This is R dash and this is R. This is 10 mm above HP and 15 mm in front of VP. That's we already know. Okay. And after that, this is your front view. We don't know the length of the front view, right? This front view from we are looking from this side, we will get the front view like this, parallel to XY line in between these two projection lines. This is our front view, but we don't know the length of the front view. If we know the front line, if we can spot the top view, we can find out this length. Okay, so we have to mark this true length in the top view. Okay, top view starting from the top view of the point R is R, and it will start from here. And what about the top view of the point S? Top view of the point S will be in this point like here, but after plane rotation, after rotating the horizontal plane by 90 degree, this point will come here. That is, this S will be above XY line. So we know the length from here to here, but we know the length of the top view. Its true length, it's 90 mm. And what about the angle here? What about the angle? This angle is phi, that is angle made with VP. So you need to take an angle phi, and you need to mark this line. Okay, 90. Then you will get this point, and you need to draw this projection line. So this is our second step. We completed the top view and front view. Okay, stand the basic figure first. This is our basic figure of line rotation. Suppose this is our point R. First procedure is make the line parallel to VP and draw the front and top view by keeping one point and rotating the another. I am keeping my point R constant, and this is R dash, and this will be S1 dash, and this is our true length. And it got a front top view. Top view is, this is R, and top view will S1. Okay. And next step is make the line parallel to HP and incline the parallel to HP, keeping the angle theta constant. So this is RS r s2, this is our true length. This true length have a front view, that front view s2, this is of the front view. So the front view will be in reduced length, and here also it will be in reduced length. This length will be equal to this length. What is this length? This is the original position of the reduced length. How to find out the original position? By finding out this for locus point, you need to transfer this length from here to here, and you need to draw a line. This is the final position of your line in reduced length. Okay, and this is the final position of the line in reduced length. This is in top view. This is r s dash, and this is s. Start to draw this line. It's a rough figure. Okay, this is our xy line. First you need to mark this point r. R is 10 mm above HP. Suppose this is 10, this is r dash, and 15 mm below xy line, 15 mm in front of VP. So this is r, this is 15. First you need to make this line parallel to VP and making an angle parallel to VP, keeping the angle with HP constant. So you will get a line here. So we know this line theta. What about this theta? Theta is here. The theta is 30 degree and phi is 45. Theta, mark the angle 30 and draw a line and find out the length is 90. Suppose here is 90. This is S1 dash. You need to draw a perpendicular. This is your projection line, and this is our top view of the first position, that is line parallel to VP and inclined to HP. So this is S1. Okay, and we next step is just mark the locus line. So immediately mark the locus line. This is our locus line. The next step is make the line parallel to HP, keeping the angle with VP constant. That means keeping the phi constant. So it will be like this. So here this is the position. So after horizontal plane, and this is the point S in second quadrant. So whatever the views, front view and top view, all the views will be above XY line. So this is the top view of the point R. And what about the top view of the point S? It will be in above XY line. So it will be the line will be in this direction. Okay, at what angle? We know the angle is 45 degree. So from here mark 45 degree and draw a line. This is our position of the line when parallel to HP and inclined to at an angle 45 degree with the VP. So here you need to measure 90. 90 means true length. 90, suppose this is true length, then this will be S2. Okay, this will be S2. And here you need to draw the projection line. This is our projection. Suppose this is our projection line, and its front view. Its front view will be, so what about the front view? Front view will be a line, straight line parallel to XY line. Above, what about this distance? This is 10 mm, right? This is because this is also 10 mm. So we will get a front view here. This is our S2 dash. Okay, so this is our locus point. This is M dash, this is M. Because the front view and top view will be above XY line. Okay, because this point S is in second quadrant. Okay, and how to find out the original position of the line? So this is the length of the original top view, and this is the length of the original front view, and you need to transfer this length from here to here. This is our locus point. So just transfer the length. This is our R dash S dash, and you need to transfer this length from here to here. This is our R S. Okay, so this is the original front view, and this is the original top view. Got it? Okay, let's start to draw the solution. First XY line. This is our XY line. First we need to mark the point R. R is 10 mm above HP and 15 mm in front of VP. 10 mm above HP and 15 mm in front of VP. Okay, this is R dash and this is R. And the next we need to make the line parallel to VP and inclined to HP, taking the angle whatever the angle is 30 degree to HP. So you need to, here you just need to draw a line in order to take the angle. Then you need to take the angle 30 degree from this line. So because the line is inclined at 30 degree to HP, because the line is inclined here, line is inclined 30 degree to HP. So you need to take the angle 30 degree, 30, and draw this line. And here, what about the length of the line? Its true length is 90. So this is 90. Mark the locus line. This is the locus line, M dash, and drop projections. Drop the projection. This is the projection, and the top view will be here. Like this is our top view. This is S1 dash and this is S1. Okay, next is make the line parallel to HP and draw the front and top view parallel to HP. So the top view will be in true length, but the point S is in second quadrant. So the front view and top view will be above XY line. So we need to draw the line not like this direction, like this direction. Okay, so what is the angle? Angle is 45 degrees. So phi is 45 degree. We are not changing the angle phi. So take 45 degree. This is 45 degree. You need to draw a line. And what about the length of the top view? The length of the top view is 90. Just mark the 90. This is our front view. This is R. This is not front view, this is top view. This is RS2. And what about the front view? Front view will be in between this projection line. Drop a projection line, and front view will be in between two projection line, and it will be here. Right? So front view will be, look here, this is the position. Line is parallel to HP and inclined to VP. Front view will be like this, because when we are looking from this side, you will see this line like this. Okay, at the distance 10 mm above XY line. Okay, this is 10 mm above XY line. So this is our point S2 dash. Okay, so this is our line. See, this is also our true length. Okay, we got the, so this is our locus point. Okay, so in this position, in this question both the locus point will be above XY line, because one point is in second quadrant. Okay, we got what? We got the length of, this is our length of the front view, and this is our length of the top view, original length, and we need to find out the position. So you need to transfer this length from here to here. Okay, this is our original S dash. This is our original S dash. And what about original top view? This is our original length of the original top view, and you need to transfer this point from here to here, this location. Okay, this is our original, top view, RS. This front view and top view will be in a straight line. Okay, it looks like quite a complicated problem, but it's not. So you need to follow the procedure exactly. Okay, so it's dimension. So this is what about the angle theta? This is angle theta, and this is angle phi. Okay, this is alpha, this is beta. If you want to know the angle, you need to measure the angle from this figure. Okay, dimension, we know the dimension. This is 10 mm above HP, 10, and this is 15 mm in front of VP, 15. And what about this length? True length will be 90, so you need to mark the true length. So true length is from here to here 90. This is R 90, and here also we know this is the true length. You need to, this is R 90. Okay, so in this problem, so what is the question? Draw the projection of the line. So this is the projection of the line. Basically we finished the question. So here, if you want to find out the trace, you can find out the trace. It's very easy. Just extend the front view of the line. Just extend the front view of the line. Find out the point at which it meets the xy line, that is h dash, and you need to extend the top view. Here you don't need to extend the top view. Okay, so here you need to extend the top view in this direction. Drop a perpendicular from here to here. This is HT. And what about VT? So you need to extend the top view and find out the point at which it meets the xy line. Here it is the point where the line meets xy line. This is our V. So you need to draw a projection. Find out the point at which the projection or the perpendicular meets the front view. So this is our VT. This is our vertical trace. If you have any doubts, you can ask in comment section. Okay, thank you.